Hello YouTube, RJ. Hey, got a really big box on the bench, bought something for the lab. Kind of big to try to unbox on camera easily. So let me get this thing unboxed for you and I'll come right back and we'll take a look at what I've purchased. Okay, if you think you've got deja vu, there's a reason for that. It means you're one of my normal viewers and you think you've seen this before. But take a good look. You haven't. Because while you're looking at an HP 428B clip-on DC milliamp meter. It's not the one you've seen before. Those that watch my channel regularly probably remember I had one of these on the bench, months ago, right after I went to the Orlando Hamcation. So I went to the Ham Fest and a gentleman gave me one of these. He gave me one that looks a lot nicer than this actually, but there was a big problem if you remember. There was no probe with it. And without this weird probe, they're no good. They're useless. So I hadn't done anything with it. Well, I happened to stumble across this one on eBay. Noticed it showed having the probe. So I reached out and asked if the probe was intact, and yes, it is. So then I started watching, and it didn't sell for a while. So I made a really low offer. And these things are not easy to sell because they normally don't have a probe. There's lots of them without a probe on eBay all over the place. There's people that want, $800 for them, but I mean, you've got them on there for $40 without a probe. So I just kept working on the guy, getting the price down and down and down to the point I was really wanting the probe. So I wasn't willing to pay much. So I kept going and going and going until I got him right down there. This one is going to be spare parts and the probe for the other nicer looking one, or vice versa, however it works out. And my idea is I think I can completely go through one of these meters using spare parts from the other and create me a nice working meter. Now they're beast and they're old and they're very specialty instruments, but they're kind of neat. They're DC. They're not AC amp meter, they're DC. But the really cool part about them is it allowed you to clamp on, in the older tube equipment and stuff, clamp on around like resistor leads and stuff. You were able to clamp onto it and read it in circuit while it was working. And it kind of has a neat way to work. Let me see if I can get over here. I'll have to stand up a little bit. I need to cut that off. But you can see this probe. Notice that this probe, it opens up. You put it over a connection, you close it up, and then it senses. And the way it senses the DC is interesting. It generates its own AC signal on one side of the ferrite clamp, and it senses on the opposite side. And so what happens is if you put a known signal oscillating, I think it's 40 kilohertz, don't quote me on that, but 40 kilohertz signal at a known level, it will vary depending on a DC current, because the DC current creates a field, it just doesn't cycle. And when that field builds up, it basically buffers the AC signal, so it varies it. And it varies it based on the amplitude of the field. And so this system creates its own signal, and then it looks at the change in it to tell you how much current in DC is running through the clamp. So pretty cool. So let me get this thing set up here. I think I'm going to open this one up, just take a peek inside, just see what it looks like. All right, I took 2 screws out of the back, pulled the top cover off, and this is what we found inside. Doesn't look molested in any way, but from what I can see, definitely it's got age and it's really dirty. This thing's going out right after I end this segment outside and we're going to pull out the old duster and put it to good use, because it is definitely very dusty in here. Looks pretty good, really does. Pretty surprised. Don't know what shape the tubes are in, but let me give you a look at the back. So there's the back. Everything looks good there. Looks like the fuses are intact. Also needs to be blown out well. So that's what I'm going to do. I'm going to take this out, blow it out good. We're going to hook a power cord up to this thing, and we're going to see if we can get this thing powered up. I'll get the variac and isolator out, and we'll bring it up slowly, make sure no caps explode on us violently, and we'll see if we can bring this thing up and see if we get any response out of it all. I'd just like to know if it's working or not. All right, I'm back, and I've got some bad news. I cleaned up that meter, everything there, no problem. But when I got looking at the probe, I cleaned the cable up real nice and everything, and I went to open it, and the plastic shell here would open up. I had no problem getting it, it opened fine, but the actual pickups wouldn't open. They actually pulled out of the sides of their shells. So I went online and I looked up disassembling. I disassembled it, and I got in there, and what I found was the probe was stuck together hard. I mean, I couldn't get it apart. I mean, I put a screwdriver in there, could not open it. And also the wires here are like, it's like the insulation melted off. And all I can figure is this probe has got in some chemicals. I don't know if somebody tried to clean it with something, or maybe it was stuck and they were trying to get, I don't know what happened, but the it softened some of the very surface, if you can see here, of the potting material and glued the sensor together. And it ate the insulation on these wires. And so I thought it was a total lost cause, and it probably is, but I'm going to go for a Hail Mary here. I got to looking closely at them. The insulation's intact right as it goes in down here. It's only above that and out. These wires are these fine wires. They're potted into this shell. Looks like the insulation survived right at the very bottom of that, and I can separate these. And so I'm going to try to clean this insulation off here, and I'm going to do a little microsurgery. What I'm going to do is I've got some of this liquid electric tape that I've used before, and what I'm going to do is I'm going to try to take and spread the wires and coat the very bottom of the middle with a little bit of it. Bring them close together but not touching, and let that set up, and then coat the outside, and then work my way up, putting coatings on, and actually try to replace this insulation. I know it's a long shot, guys, but these things are like hen teeth, and you know, if this doesn't work, if I can't get this probe to work, both of these units are going to do me no good at all. So, you know, it's worth the Hail Mary to me. I'm gonna give it a try. Let me get set up a little better here, get this opened up and such, and I'm gonna work on it a little. We'll see how we make out. So hang in there with me. We'll see where we get. Okay, that's it. Just a matter of giving this time to completely set up. It's going to take quite a few hours. So we'll pick this up again, maybe even tomorrow. Okay, it's the next day. Went ahead and let that dry. Let's get it up here for you. See this camera right here, good. And went in and put it back together. It now opens and works, as you can see. Well, the jaw's open. Does it work? I don't know. I did put a ohm meter across the pins here. I was getting pretty close to the same thing, 5 ohms, 5 ohms, 5 ohms. I had one that was like 9 ohms. I looked in the service manual, and it said it should be around 6 ohms, a little here or there. It said if you see over 3 times that, then you probably got an open coil. So I didn't see 3 times that. I saw like around 8, 9 ohms. So let's cross our fingers. Let's hope, you know. So anyway, I went ahead while that was going on and put a little more cleaning effort into the meter. Looks much better. Pretty happy with it looks. I mean, everything else looks really good. I've got spare parts. I've got the other unit over here. It's a different color. It's the blue one here. This is the one that was given to me. And either this is going to be in the long run, the unit, or depending on the shape of this one may be it. Nice part is I got enough spare parts there. I should be able to get one of these working if this probe works. If this probe doesn't work, we're done. These probes are just unicorns, man. So anyway, let's get on with it. What I've got set up over here for you is I've got my isolation transformer, my variac set up, my dim bulb tester over here. I've got this thing hooked into all of that, playing the safe side of things before we turn it on. So what I'm going to do is I'm going to go ahead and going to turn this on where I'm not touching the unit when I power it up. I'll use the dim bulb switch here to power it up when I'm ready. I'm going to go ahead and bring on power here. and bring up a little bit of voltage, enough to get this booted. And I'm going to bring on my isolation transformer. And that way I can tell how much voltage and current's being drawn and all of that. And so I don't have but 30 volts. Let's take it down a little bit more. About 25, close to 24.1. And we're pulling 0.07 amps, it says, or 1 watt. So let's power this thing up. Cross our fingers. Watch the dim bulb. I don't see any glowing at all. Current hasn't come up at all. So let's start bringing up a little bit more voltage. I'm going to keep an eye on the dim bulb and the current draw. Going to level out about 46 volts going, and I'm going to let that sit a minute. These old capacitors and stuff, if they're going to form a little, I'm going to let them. Okay, I'm pulling 0.04 amps. I'm pulling almost 2 watts. Now I'm at 60 volts. Dim bulb's not glowing. Indicator's not lit up here yet. Coming up. There's 78. About 3 watts. Still no indication here. Don't see smoke. Don't see anything yet. Coming up in voltage a little more. There's around 90. I would have thought we would start seeing an indication up here. There's 100. Almost like it's not getting any power at all. I'm pulling 4.89 watts. Coming on up. There's 113. There's 117 volts right there. We should be operational. I'm not pulling, but 5.76 watts. Yeah, I don't think we're on. Well, there we go. Something's going on. I just got dim bulb indication and then it slacked back down. Now I'm pulling 35 watts. Maybe some dirty contacts. Maybe it wasn't actually making. I'm pulling some current now. I'm getting any indication on the meter whatsoever. Pulling 33 watts. 5 watts. 36. 40 watts. 36 watts. Not getting, well, I'm getting a little glow there. The voltage up to full 120 volts. 35 watts of power. I am getting a little bit of a glow out of the indicator light here. Power off, I'm getting 6 watts. Powered on, surges to about 45 watts and down to 30 watts. So she's taking power, but she's not. Give it a little bit of time. Old technical tap. Zero's not doing anything at all. Okay. Well, I guess we're going to be digging into this and see what we can find. One thing I might want to do is take the dim bulb socket out now that we know we're doing okay. In case that's prevent it from coming on. Let's give it full current before we do anything else. Okay. Surge to 57 that time. Dim bulb's a little brighter this time. Just pulling 37 watts. Let's give it a minute for things to warm up. Pretty state about 36.5 watts. Still no indication. More of the needle stuck. No, it's moving. It just takes a good rock to move it. Seeing no indication. Needle doesn't move when I turn the switch on or off at all. I guess I've got a choice here. I can either rig up the other one and we can see if she comes on and how it acts and go from there. I think that's a good idea. Let's do that. Let's take the probe off of this one, put the dim bulb back up here, swap in the other one, and we can go ahead and test bringing the other one up just to see what we get. So let me take a break, rig all this back up, be right back with you.